I would like to offer you a warm welcome on behalf of the EGP Group of Engineering New Zealand. My name's Graham McMillan and I will be your host for this webinar for today. If you have any questions, please type them in the chat areas in the question and answers, and we will endeavour to answer these questions after the presentations have concluded in a formal question time with answers. Now, on board with me today are our guests, Paul Tune and Ed Bermudez, along with Kelly Pilkington, another committee member assisting me. Today, our topics for discussion is safety and design. And we are pleased shortly to be joined by Ed from the international firm of the Wally Group. And I believe it's got 23,000 employees, so it's quite a large group. But firstly, we have a short interview with Paul Tune, a self-employed consulting structural engineer from the Bay of Islands in the far north, which I am led to believe, Paul, you enjoy the same great weather as we do here in Invercargill. Anyway, and to host this brief interview, I will now hand over to Kelly. A warm welcome to Kelly. Thank you.
Hi, everyone. Welcome. As Graham said, before we get stuck into today's webinar, we have, I'll just be asking Paul a couple of short questions. So, Paul, hi, great to have you here.
Hi, Kelly.
Would you be able to start, just tell us a bit more about what you do up in the Bay of Islands?
Yes, I'm a structural engineer in the far north, and my one-man firm is called Structural Sense. We are based in Haruru Falls, just north of Paia. Up here in the far north, we have a group of 6 to 7 small practitioners, mainly structural engineers. We also have a few geotechnical engineers as well. And we catch up like once a month to discuss anything engineering lives. And a few of us, including me, we are also on the EGP Slack channel.
Great. My next question for you is, a general practitioner, do you think that the technical support currently available from the various engineering bodies is appropriate for you?
Yeah, I've been a member of Engineering New Zealand, NZECE and CSOC for a long time. But since I moved into a small residential industry, I started to feel that the technical support and discussions in those bodies kind of less relevant to my EGP type works. I feel like the discussions for those bodies are more on the complex and highly academic and or big scale issues and discussions. While my work, I kind of simplify and optimize engineering solutions for people's homes. So quite simple. And that's why when I first saw EGP, I kind of knew straight away this is kind of interest group for me.
Yeah, that's awesome to hear. My final question for you then is just if you could tell us a bit more about what you've found the most useful thing since you've joined EGP.
Yes, so I've been with EGP from the beginning. Right? And what I found is the EGP Slack channel is very useful. It has been a place that I feel comfortable asking simple questions and questions applicable to me as a small practitioner. And the Slack channel is also a place I feel comfortable participating, sharing what I know. And so I can get a sense of belonging to an engineering community. And many times our group up here, we take discussions in the EGP Slack channel and we discuss further in our group meeting, which happen once a month. Yep.
Awesome. Cheers for that, Paul.
Thanks.
I'll hand back to you, Graham.
Yeah, thanks, Kelly. We do thank you, Paul, for your enthusiasm. And I think I'm a bit like you and a lot of us do find it's a nice group to meet other engineers and be able to discuss and just, you know, think tank simple solutions with each other. But it's now my pleasure to introduce our guest speaker, Ed Bermudez, with us today to talk about safety and design. It's quite a high-tech session, I believe, and Ed works for Woolies and has made this a subject, a speciality, having presented it to similar groups on this topic. I'd like to especially welcome Ed to his presentation. Thank you, Ed.
So now mai haere mai, kia ora koutou. So thank you very much for the opportunity to present for this fantastic forum. So I'll normally with presentations that we do within our company, either internal or external, we always like to start the presentation with a safety moment or an ambition moment. So I picked one today that sort of helps me segue into the topic. And although my background as a mechanical engineer, and I introduce a little bit more about myself after the safety moment, it's mainly in sort of heavy industrial topics or themes. I picked one that's a little bit outside, and I believe it's you know, we've got a high volume of people in the audience that are sort of in the perhaps residential and commercial setting. So hopefully this is something that resonates with you. I'm going to start with a short video and then I'll just show some learning. So I hope you enjoy this. Hopefully most of you know of the Grenfell disaster, but you know, there was a case hearing and some of the it highlighted several pitfalls on the side of the design firm. And some of these, you know, there's lots of them, but I picked a few that hopefully sets the scene for the topic today. You know, one of them was project responsibility missing within the organization. What actually is the design organization responsible for in terms of the design? The project designer had limited knowledge of the relevant building codes mentioned in the specification. I guess it didn't help that there is a lot of gray areas when we're talking about brownfield when you have a project where you are modifying an existing asset or system. This is something that I'm sure everyone here is acutely aware about, the pressures within budget from the client side. So you know, the pressures of reducing cost and pushing for schedule to be met. You know, it's for us as professionals, we've got the duty to, yes, there is a practicality that we need to move on with the projects, but there's certain things that we need to be very clear what we can and can't do. And then there's a scope gap between the design firm and the fire system experts. You know, some of the things that were heard in the hearing, you know, they reckon that retrospectively being that is based on an existing building. So we're looking at the fire safety design for a building that is already there. It was really an informative piece of work to look at the fire safety design of the refurbished building for the design team rather than a holistic fire safety audit. And you know, it's just a reminder of whatever we are requested to design. It's never in isolation. It is a system, and we need to consider that as a system. So hopefully that sets the scene and sort of resonates with some of the things that we're going to be talking about today. So a little bit about myself and the company I work for. So thanks, Graham. So yeah, Worley is an international company. We actually have now 42,000 people across the globe. In New Zealand, we are a sort of a smaller group, around 350 people. And about myself specifically, so I'm originally from Venezuela in South America. My background, I'm a mechanical engineer, and my background is mainly comes from reliability and maintenance. But I've been involved in mechanical and infrastructure projects in South America, the Middle East, which is where I've met my Kiwi wife and made my way over here to this beautiful country. More lately, I have been I've been managing projects on a number of industries here in New Zealand. Anywhere from pulp and paper, infrastructures, ports and marine, and food and beverage, and other things. Even though I come from an oil and gas sort of background, back at home, I've been fortunate enough to be exposed to a lot of different industries. But lately, I've been heading the digital strategy for Worley, New Zealand. And I guess I'm going to give you a little bit of a spin on how we live in a fantastic time where there are digital technologies that are making it easier to bring everyone on the same page. So that's going to be the theme that I'm going to give you a little bit. And we have been fortunate enough as Worley to be working closely with WorkSafe and Engineering New Zealand in trying to wind up the awareness of safety and design and sort of trying to bring safety and design culture across our profession. And with that, I guess why we feel safety and design is important. And I'm going to talk a little bit about some of the processes that we've got in Worley and how everything that we do actually impacts the assets that we are working on. So in terms of safety and design, it supports one of our company values, which is the value of life, and thus reduces injuries and deaths. It allows us to address hazards very early in the piece, while they just even from concept, way before they materialize into the real asset, so we can actually do something about it at the right time. It is a professional obligation that we have as engineers and designers. It's a legislative requirement in many parts of the world and in New Zealand certainly. It improves the use of the facility given the consideration of the human interface, because at the end of the day, we are designing that so the interface between the asset and us people is as safe as possible. And last but not least, and we have to be aware that a lot of decisions made are financially or business driven. It makes business sense. It impacts our reputation and our customer trust as project professionals. It reduces life cycle costs and cost to manage injuries and lost time and damaged assets and cost of the environment impact. I mean, just looking at the example of the Grenfell disaster, look at all the, it escalated to even the Prime Minister and sort of being judged on how quickly she reacted or didn't react. So, and then it sort of allows us to have all these boundaries that gives us the opportunity to be more innovative in the things that we're doing, reduce costs if we treat them early in the piece. We improve the usability of and the productivity of the asset that we're designing. We try to, as much as possible, eliminate the risks from the source. We comply with the legislation, we have safer workplaces, and we reduce injuries and fatalities. So there are a few major incidents which have occurred in the last 50 years, and many involve multiple fatalities to site personnel, and some involve fatalities in the community. And these have actually shaped the way we now design and engineer things. So each of these have had major implications for how we perform tasks related to safety in design. For example, one aspect, from the industry that I come from, the destruction of the Piper Alpha platform resulted in the formation of the UK Health and Safety Executive and development of the requirement of a safety case. And, some of you that might be familiar with process safety. This was also applied in Victoria and Australia following the Longford fire in '98 with the establishment of the Major Hazer Facility license. A little bit closer to us is the Fukushima nuclear power plant incident, highlighted why we need to design, considering also the high consequences, those that are possible but not unlikely events. We also need to consider them. And we talked about on the safety moment, the Grenfell Tower fire exposed failure in the application of management of change to older buildings. And our review found very complex silos, regulatory systems which were at times contradictory. Many of these major incidents prompted significant changes to national workplace health and safety laws, which were adopted across other jurisdictions. And we are very aware with that. And we have a regulatory bodies that are always keeping us honest. And these exemplify why safety in design is so important for us. So Worley has what we call a SEAL framework, and it is described sort of using this figure that I've got here. It sort of has a strong foundation center on people and compliance, a sound culture, that we've got the right leaders, properly educated people dealing with the right thing. We make sure that we're compliant with the local laws and obligations and standards. And I guess it sits on 3 pillars that support that roof. And one of them is safety in design, which I'll talk a bit more about it. But we also have, the technical integrity in to make sure that we have a sustainable design. It's more than ever, everyone's being scrutinized about the sustainability of the things that we're designing. And I guess at the same time, having the right systems, either from the customer and us as designers that are, making sure that they're being applied. So, the SiD pillar, which is what I'll be talking about now, or I'm talking about today, it's, we deliver it through identifying and managing the hazards over the whole life cycle. And that we're using specific discipline standards that, and so we can present best practices for safe design. So what do we really mean by safe engineering design or safety in design? So there's a few sort of definitions that are out there, but I'm just going to name a few just to get us all on the same page. So SiD sort of encompasses the design effort that manages the source of the hazard that's being exposed. So we want to make sure that we identify the risks from its source and trying to manage it. It involves the integration of control measures early in the design process, so we can eliminate it if possible, and if it's not practical, at least minimize the risk to health and safety throughout the life of the asset. It focuses on addressing, again, hazards during the design process. So going back to, let's understand where the hazards are as early as possible. And some of the outcomes can include, what a lot of us would call fail-safe design. So anticipating when a problem can occur and make sure that it fails on the safe side. And it improves safety via communicating how to use design safety to the actual users, because if we're not close enough to the people that are going to be using and maintaining and decommissioning and even constructing this project or asset, then we're going to be missing out on addressing things at the early stage. It feels and sounds a bit trivial, but more often than not, we are asked to redesign things late in the piece, and it just becomes more costly. So I'm making emphasis about learning from major incidents because they're the best source of information to avoid things like that to happen again. So in the context of safety in design, major incident is defined as an event that's typically catastrophic, involving the loss of containment of hazardous material or a fire or sort of something really catastrophic. And as practicing engineering and design professionals, we had the duty to familiarize ourselves with these major incidents and the learnings from it, because as engineers, we should be curious by nature, and nowadays there's so much information out there that we should, there's pretty much no excuse about the availability of information. If anything, the problem is that there's so much of it. So yeah, in that sense, just a little bit about this is coming from our SEAL sort of standards and safety in design. is a set of activities defined under the overarching process that include the integration of hazard identification and risk assessment methods early. And I keep coming back to the early in the design development. I guess this creates opportunities for engineers and designers to eliminate or minimize the asset lifecycle risks through their design efforts and deliver safer design solutions. And I guess going back to, we want to make sure that whatever we're designing, we are considering how it's being fabricated, how it's being installed, how it's being constructed. Is it going to be safe to be constructed, operated, maintained? And after that, as it has reached its end of life, is it going to be safe to decommission and demolish? We've learned a lot about certain materials being used in the past. So obviously we don't use asbestos anymore, but we need to think about all the way there. And yes, there's going to be pressures about costs and budgets, but if we at least consider it and communicate it, then we can make an educated decision and we qualify the decisions that we make. So there's two lenses that we can identify safety and design with, but they both have the common goal of reducing hazards, right? And for both of them, there's one thing that influences both. So process safety, we talk about some of the tools and the language on process safety is explosion and fires and fatalities and major incidents. And, some of the systems and procedures that are used to try to identify and mitigate these hazards and design reviews, management of change, terms like as low as reasonably possible, risk assessment and things like that. And then on the occupational safety is all about making sure that while things are being maintained and operated, we are providing, ergonomics and we're minimizing slips and trips and stuff like that, how people are actually interacting with the asset. But what is common between these two is that at the end of the day, it's the human asset or human machine interaction. And that's the risk. Can we try to eliminate an interactions that is potentially risky? And that's what we need to be looking at. And I guess it is the intent that we compare the aspects of safety and design to health and safety. Often different teams have different focus. Operations may be more concerned about the health and safety, and design teams and process engineers may be more focused on the process safety and the major incidents. So it's finding that balance between the high probability, low severity things of occupational safety, which is not always the case, but it's sort of why, generally speaking, that's the case. And how do we balance the high severity, low probability risks? I'm going to give you an example and why it's important that we have all disciplines apply safety and design practices and are considering each other. Let's make, for example, when we are tasked to design, I don't know, a fuel tank for a transport depot or a oxygen tank for a hospital or something. We've got quite a number of disciplines playing part on this, and unless we understand what the other discipline is needed, we might be not setting them for a safe outcome. Say on the process safety side, we might need to understand the likelihood of certain failures or having a loss of containment and how to react to that. On the electrical side, we need to ensure that we've got sufficient power and there is a backup supply. If something goes wrong in, I don't know, the process people or the instrumentation people were relying on a critical level sensor that doesn't have power anymore and then wouldn't react. So, and then on the mechanical side, we need to make sure that the material strength is suitable for all the different pressures to make sure that we don't have a loss of containment. Especially here in New Zealand, all the seismic and wind considerations that we need to have. Are we sitting on the right structure? Is it compliant? Are we reusing an existing system? So all of these things will affect one another. So if we haven't, say, consider the implications of piping movement or expansion and compression of these pipes, and how flexible the tank is, for example, all of these things will have an implication. So unless we at least have processes in place that will trigger us to ask the right questions to the right disciplines, then we will miss in some of these things. There's several principles that apply as part of safety and design, and some of these are actually in legislation, in HAZWAT, and Health and Safety and Work Act. So, it all depends on what we're trying to achieve, but, we can use what if analysis, so we can consider all the events, all possible events. We can identify the hazards and the risks, and how we would mitigate them if it was the case. But, and it might be the case that we cannot practically mitigate or eliminate some of these, but the fact that we have identified them helps, people like first responders, say in Grenfell, if there was sufficient information about the cladding and how it could sort of fuel the fire further up, maybe there would have been different approaches. The hierarchy of control, how are we going to address the hazards? Can we eliminate them from the source, or is it not practical and we want to use sort of PPE or administrative controls? We want to make sure that we can, as much as possible, trying to have safer designs from the very beginning, and how do we encourage and promote safety with the things that we're doing? Do we have layers of protection? And, as much as possible, address the risk to the point where it's as low as reasonably practical. Now, a few more thoughts, and these are some of the things that we have in our toolbox to help, because at the end of the day, this is a people's business. So we're trying to keep people safe, but we also have people doing the design. People that are under a set of expectations and work pressures and schedule pressures and budget pressures. So we have to acknowledge, the same way that we're trying to design something that for an operator to be safer, we also need to acknowledge that as designers and engineers, we're not isolated to the work that we're doing. So how do we support and have systems in place to help prompt the right questions in the right stage, even from the planning stage all the way to execution? So we've got, and every project will be different, but, as a minimum, we want to make sure that we can define design criteria from the very, very early stage, that we can agree with the customers and the users and the stakeholders what are the basis of our design, and there's certain prompts for it. We've got hazard identification standards, HAZUP standards, design review, how we're going to be reviewing our design, in what stage. Each discipline would, in our case, has a set of safety and design standards that prompt us to do certain things. If we're dealing with hazardous substances or hazardous areas, there's a standard and checklist for it. And how we're going to be managing risks and identifying them, which is very, very important. So a few more thoughts. Do not get sucked into time pressures without due diligence. And we want to make sure that we apply these to the project risks. We want to follow accepted project roadmaps. This will look different for small jobs, yes, and medium ones and large. But as a minimum, we want to agree on a concept and how we would define the job and how we're going to detail it and execute it. Do not shortcut on concept and definition phases. It's really important. If you are engaged from the concept design, having things written down and agreed early will help the rest of the phases immensely. And I guess in addition to design review, aim to complete an early constructability review in the definition phase if possible. And nowadays, designing in 3D is a lot easier and less expensive. So not everyone knows how to read a process flow diagram or a PNID or a layout drawing or a 2D drawing for that matter. I mean, I've been in projects where we've agreed on a certain pipe rack or a conveyor that needs to go from here to there on a 2D drawing, and the stakeholders have signed it. And then when we're constructing, they're stopping the job because, no, I can't accept that. That's too low. I need to have clearance for this forklift to come in and out. I said, but you signed this here. So yeah, but I didn't appreciate it was this low. So I guess let's use as much as we can, trying to use the same language so we've got the right stakeholders identifying things at the same time. This is a little bit of a busy slide, but I guess one is to acknowledge and appreciate the complexity of the things that could happen. But at the same time, not to freak out too much, because at the end of the day, so long we've got the prompts, and I guess that's the idea of having systems and processes. And I know every project and every design firm, may not have the luxury to have different people for different things. But let's acknowledge that from the beginning, that there are certain things that we need to look for. And some of these things is everyone within client and designers understand what are we trying to achieve. It's the scope of work understood. Do we understand what are the safety and risks, and with pressure protection, if we're trying to design a pressure vessel, for example, or is there any environmental constraints that we need to know? Emissions. What is the duty that we're trying to do? In the sense of when we're designing process systems, and there's a whole bunch of things that we want to make sure that we understand it early, and we agree that from the first time. So I'm going to show a few use cases, and again, I'm going to give it my digital spin, and I guess it's just to show you that nowadays we've got tools that would help us. And I think that the bottom line is ask the right questions at the right time, early enough, and as much as possible, try to communicate with the right stakeholders at a language and illustrating in such a manner that they can see what's going to happen. That example of 2D drawings and people signing off things and then realizing, oh, I didn't realize that we could do that. So there's some, we can start with some key lessons from something really simple. Like in this particular case, the detailing of a step near a doorway was just omitted, and we didn't. Whoever was designing that just didn't think about the fact that we had a step straight away after opening a door, and because we needed to have a drain there, it actually caused a trip hazard. So there was an incident, someone fractured the ankle, and then it became quite a big problem. So the root cause was there was a poor detail and lack of identifying the hazard and controlling it from the beginning. And yes, at the end of the day, they were able to modify it in such a way that there's no, we don't have that step straight away after the door. But then, now the drainage is compromised because you don't have that surface area, to capture it all. You can still do it, but you might end up with a puddle of water. So better treat it early than afterwards. On this particular one, I just wanted to show you something. Let me just change the laser pointer. Hopefully we can get to see this quickly. So this was an interesting one. It's a couple of fuel tanks that collapsed under construction in a refinery in Perth. And I guess I think the news report was not going to go, but the interesting thing about this is that they had a first tank collapsing in the middle of construction, and then 6 weeks later, a second one collapsed. So just think about, obviously, the reason why the first one collapsed, did they have the right constructability review for that particular area, assessing the wind? But then second, after the first one collapsed, nothing was done to prevent, or first to identify what happened, and then to prevent that would happen with other tanks and actually happen again. So, again, when something does happen, stop and reassess the risks, put measures in place to mitigate similar events to happen, pre-plan a construction sequence as much as possible, And those risks that still exist after tools are put down, at the end of the shift, you have to also consider those, because it's not the matter of there's no more workers there anymore. That's all right, she'll be right. That's the sort of things that we need to look after. This is a very this is an oil and gas example, but I think in principle, generic principle is actually quite a good one, because for this particular one, a client was building a separation loop for a petroleum facility and needed a 30-meter vertical stabilizer column. Normally, these things will be built and then they will be dressed up after they're erected. And what I mean by dressed up is putting all the peripherals and the walkways and all this sort of stuff. But that costs money. It means that you need to scaffold the thing. You need to make sure that it's safe for the fabricators to do the job. But by approaching the design from the very beginning and considering constructability at the early stage, the team was able to design it in such a way that we could dress it up from being horizontal. And not only that, there was also consider how to transport it. So it could be transported safe and try to minimize the amount of site work. And it was quite fascinating to see how was that addressed very early stage, and then the erection and construction was properly planned, and it could be done on budget and on schedule. Another example that I wanted to show you is that on this particular one, this is close to my heart because I managed this project, and that's me with a little 360 camera on top of my helmet. There's an industrial lumber processing facility that is planning to replace their existing log infeed for the sawmill, and this sawmill is on the end of life. And it is a brownfield project that requires the design to take into consideration that we're going to be constructing around an operational area. So just to give you a little bit of context, so this is an aerial view of the existing log infeed. This, let me put the pointer again. Hopefully, okay. So this is the existing log infeed, and this building here, it's just part of the initial part of the sawmill. So as you can appreciate, we've got extremely big logging trucks that pick up 1-ton logs, bundles of logs, and place them into this log infeed that then they're singularized and they push in a mechanical conveyor one by one. The new log infeed needs to be constructed right beside the existing operation. It's twice the size, and this is considering that we're going to have to construct this while this is still in operation, because we only have 2 weeks shutdown opportunity to do the integration here inside the building. So this was a very interesting job because we actually managed to get hold of aerial footage from when the original plant was built. We were luckily, some of the colleagues in our office used to work for this plant in previous lives, and they knew that there were certain things in demolition that weren't actually removed. So on this particular case, the concept was that we were going to provide power from an electrical room over here, and we were going to trench and go over here. We actually managed to get hold of the old 1970s drawings, and we managed to model it, and we could early in the concept phase make the change from providing power from here is running a cable over here and putting a new transformer for power in the switch room here. So I guess, again, having that prompting how we're going to construct this safely while this is being, this other plant still being operated was key for this. So I wanted to show you something quickly before we finish the presentation. So it's just to give you the idea of how powerful technology could be to make decisions. So nowadays, we're actually able to capture the construction as we go, and we are able to have constructability reviews with the right people, showing what's going to be in place and making decisions about how we're going to, place specific precast members or how we're going to lift them. We can actually push things into place and transport it and make decisions, things like this temporary walkways needed to be scaffolded. We were able to plan the scaffolding before, put them in place within the scan data and make a decision. And then with these things, nowadays, we're lucky enough that we had we have been working with these for quite a while. So it's because we're already designing in 3D, just placing this into reality just provides a different level of context for people. And that has meant that we have been able to be agile in the decisions that we're making when the contractor's been excavating and finding things that we weren't anticipating, because everyone is looking at this at the same time. And I haven't even talked about the fact how COVID has affected the last 2 years worth of our projects, where people are not allowed to be on site and make decisions. So nowadays we can actually capture site and bring context to people without bringing people to site. With that, I'm going to just want to give you a little bit of context. So the green stuff, it's been designed overseas. We are in charge of designing all the other stuff to support that. And again, just bringing that context to the people in Austria that are designing this, and it's been engaged by the customer, and like we can actually bring them the limitations that we've got on site. We have been able to make decisions. Look, with that, I want to make sure that we've got a few minutes for questions. I want to show you one other thing, and I know this is oil and gas related, but it shows you the power of technology if we can bring everyone on the same page. We had a situation where we were asked to design the integration between a offshore gas platform and a jackup rig, though it was overseas and was going to be used for a new drilling campaign. The rig was berthed in Scotland, and we got someone to scan the whole rig and give us a 3D scan of that rig, and we actually were able to design everything in 3D. But we designed based on what we capture statically, what was there. Now, we weren't aware of things that needed to move within that rig. So how do we get that input? We actually got I'm going to show you a quick video. It's 2 minutes, and then we'll get into questions and answers. But this. Oh, sorry. Trying to get there you go. Laser pointer.
And you can see it's very accurate.
Yeah.
It's very accurate in its layover.
All right, and you can see a nice little gap there. That's what I like to see.
Yeah, look back to the top, Jamie, and see the gap between the cantilever and the constar. You can hear us.
Sort of. I know you mentioned the cantilever. Let me walk over there.
Yeah.
I'll just try and take it slow. This guy's here are probably laughing at me.
I find myself leaning backwards.
Yeah.
Yeah,
whilst I'm watching.
Oh.
Oh yeah.
Now, Steve, we were even up the top, and you can see.
So I guess the takeaway from this is that we were able to pick up things that our designers didn't pick up before the rig actually arrived on site, and we were able to fix it before, still during fabrication phase. And it meant that a plan that we had to do the integration in 2 weeks, and you can only imagine how much it cost for one of these rigs per day. We were able to, a plan that was for 2 weeks, make it minimize it to 6.5 days, because it pretty much most of it actually fit within millimeters, because we were able to get input from the overseas operator to say, look, this is not going to work because I need this particular item to swing around and there's not enough swing radius. You can't weld in here, we're going to have to put something in there before you can weld into this surface. These sort of things that, you know, as much as you can bring experienced people to anticipate problems, unless you bring the, you know, people that are actually dealing with the integration of things, you might miss certain things. And with that,
Right.
hopefully I haven't bored you too much. Just want to finish with some final notes. So, you know, I cannot emphasize enough, plan your work and work the plan. Very important. Ensure that all the project participants and stakeholders are fully informed of all necessary project information as early as possible. Promote safety culture in the workplace and share the wide sort of outlook and what the hazards might be with the daily interactions from, you know, from home and the workplace, and return that. So safety and design needs to come in the early stage. Investigation into the causes of man-made disasters. It's an invaluable source of information to make sure that we minimize the likelihood of things like this happen again. And safety and design is aligned with safe and sustainable engineering for the whole facility asset lifecycle. And that's me. So hopefully we've got a few minutes for.
Ed, that was a very passionate discussion, and with all the 3D, I think that's a unique way to do things, and I'm doing a little bit of that myself with 3D scanning. But I like the plan to work and work to plan. That's a very important part of engineering, is checking. Now we've got 2 or 3 questions here, so I'll just fire them off so you can listen to them.
Sure.
Where does audits fit into the SiD framework? I've been involved with a number of SiDs for so many years on various projects, but never seen an SiD audit being conducted to verify how realistic were the closeout actions versus what was achieved. So when do you think this needs to happen?
Look, I think it needs to happen across the project life cycle, and there's different audits. I can only speak about the processes that we've got within, and I appreciate that there's different size firms that, you know, may have different ways of doing things, but we do have people within our business that are completely unrelated to the projects that perform audits depending on the size of the job at different times, and because they're completely detached to the project, they don't have the emotional attachment of, oh no, I'll get to that little piece of paper afterwards, and you don't do it. So we actually get internal auditors to check that we have the right checks and balances in the right time. Obviously, there's audits, like it might be that there's a regulatory, or, you know, the enforcement officers or whatever might have a different frequency. But internally speaking, it all depends on the size of the project, and we would have multiple audits being done on us.
Right, just moving on to the next question. In the example, when you were looking at the loss of containment in the tank, does it mean if I'm a structural engineer, I've addressed the requirements of the building code, such as design for seismic wind, whatever loads, I have applied SiD, or do I need to do something extra?
Look, I think the message that I would give is, and maybe I'm repeating myself too much, but I think that's probably the only way that the message will go across, is communication between disciplines. I was in a situation where we were serving a client that had, they had tanks that were built in the 1970s, which means that we needed to review the grandfathering clause, or at the time, to make sure that they would comply at the time, and then address the risks associated today to see what was practical enough for the regulator to accept certain things. But it was a mammoth work between the mechanical engineers looking after the integrity of the tank and the structural engineers making sure that we have the right anchorage. And nowadays there are very innovative solutions there to retrofit certain things that will help certain parameters. So communication, make sure that the right people are included as early as possible.
Next question, Ed. Thanks for the presentation. Really enjoyed the talk. As a design consultant involved in the design phase of a plant, either mechanical, process engineering, I understand the project life cycle approach to safety in design. Inherently safer design from early stage and the responsibility of designers in HSWA. A question, how do you see the commercial tension or commercial pressure during the construction phase as a design consultant? How do you deal with the fear of legal liabilities in such discussion with the client? Also, during the operation phase, the design consultant may have very limited access to the contractors who are engaged for ongoing maintenance. Do you see a resolution to this problem of separation between the designer of the plant and the downstream users?
This is I'm sure it's the daily conundrum in the lives of project people, especially, I mean, as a project manager, being in between the engineers and my client, is that constant tension about how long it takes to do something safely and budget and schedule constraint. I go back to communication. If we can communicate and illustrate the complexities of the things that the tasks that we have ahead and our obligations according to standards and acts and legislation to the client, and qualify things why we're doing things early enough, you know, at the end of the day, you've got a contractual and a legislative obligation to that client to do a safe design, and just make sure that you can qualify all possible options, and if possible, illustrate it with a 3D model, with a sketch. I think a lot of us engineers sometimes struggle with communicating to simpler terms with clients and stakeholders. Let's make a bigger effort to bring the right people to help us communicate that. That'll be my advice.
Yes, well, there's no more questions listed, but just one from myself, Ed. As structural designers or mechanical designers, do you ever consider the weak link design concept and how that fits into your designers' thinking and protection going forward in the safety systems to put forward for maintenance considerations? So when I infer weak link, you know, something we realize, particularly in earthquakes, where this building may be vulnerable or the first point of vulnerability exists.
Look, I'll try to give you, I guess, my input based on this past project that I had on the lumber facility. I go back to, as a mechanical engineer trying to project manage a mainly civil structural project, is trying to get in my head, understand in my head what the possible scenarios are and risk of consequences, and trying to deal with it like that a lot, and bringing the client along with it. I'm quite passionate about bringing, you know, the fact that technology is helping us communicate things a lot easier, is because we can then bring the right people on the table. We had a couple of cases where we had to make a design change because of what was found after excavating, and you know, my engineers weren't comfortable about not putting something that, you know, was going to make it more difficult. So we used the model and certain photographs just to put things in place and say, if that was to fail here, all of this would suffer. Are you prepared to deal with that? And then the conversation just changed. I think the challenge that we've got is to bring the people on the table and everyone's on the same page. And luckily, I mean, I'm passionate and curious enough about trying different things. And I think nowadays technology is becoming more usable and easy to use, I guess.
Well, Ed, I think that wraps it up for today. And I do thank you for your passionate delivery, because it did show, and your background and your research of your presentation is quite wide. So I thank you again, and thank you very much for taking as the main speaker at our EGP group. Just like to bring to others, on the 12th of October, we have another seminar, and it's called Starting Up a New Sole Practitioner's Business. So the startup of everything to do with a new business, I think that would be interesting to a lot of consultants out there. And one other thing before I close, all these webinars are available on the EGP website, so you can go back and see them. So they are recorded. So, so with that, we'll just hand over to Bernadette for the closing of the meeting. Thank you very much for attending. I wish you all the best.
Thanks, Graham, for the opportunity.
Right.
It's my pleasure.